right, so this is section 4.2, modeling with linear functions. And so the first thing, remember the slope-intercept form of a linear function. So we have f of x equals mx plus b. So just as a reminder, b is the y-intercept. And that's where the input value is 0. M is the slope, also known as the rate of change. That's the change in y over the change in x, or any of the other many representations we've seen. F of x is the output of the function, and x is the input of the function. So with all of that, we should be able to tackle some of these problems. One additional note is that remember that the x-intercept is where the output value is 0, kind of in contrast to the y-intercept where the input is 0. So first thing, example number 1, if we're looking at a town's population, and we know that in 2004, the population was 6,200. 2009, it had grown. So let's figure out the input and output so we can build our model. So input of the year 2004, we have an output of 6,200 for the population. So this will be year, and this will be population. And so this will be in 2009, we had 8,100. So one thing that we'll see sometimes is when we're working with like these big numbers like years, we can adjust this to, instead of the input being the year itself, we can define the input to be the years maybe since 2004. It's perfectly fine for us to do that. So instead of 2004, this is 0. And then, of course, this would be 5 because 2009 is 5 years after. And so we now have a new set of inputs that are a little bit easier to work with because they're smaller. And so building the linear model, this is something we learned in the last section. So for the slope, we'll just do the difference in the outputs divided by the difference in the inputs. And that's going to give us a slope of 380. And then, of course, we can just go back and solve for our y-intercept using the slope and either of the 2 points. And so I'm going to pick 0 and the 6,200 because that just makes things really easy. You could choose either one you wanted. And so b is 6,200. And then I can actually write the model. So this would be y equals 380x plus 6,200. And, we can redefine this y and x to be a little bit more meaningful, right? So we could call the output now, we could call that P of t, right? The population is a function of time, and we can call this t. And we can rewrite this entire thing down here to where that's P of t is equal to 380t plus 6,200. So then it wants us to predict the population in 2013. Now remember, we've redefined t to be the number of years since 2004. So, how long has it been since 2004 here? Just doing that calculation off the side, it would be about 9 years. So in this case, that would mean t equals 9. So we'll just plug that into our function or our model that we built that gives us the population. And then, that should be a plus, my bad. And, just perform that calculation, and that's going to give me 9620, and that's going to be my population, people in the year 2013. So then we want to identify the year in which the population will reach 15,000. So that means that the population P of t equals 15,000 people, and just using our same function, except now we have an output value. This would be 380t plus 6,200, except now I'm looking for t, the number of years. Solving with the normal rules of algebra, we'll end up with about 23.2 equals t. And so that's about 23 years after. Remember, we defined this to be 23 years after 2004. So that'd be around the year 2027. Right. And so that's using a model to predict population. So now, if you want to pause the video and try this example real quick, pause it, give it a shot, and then check your answer. I'll give you a second to do that. Okay, so this should be C of x equals 0.25x plus 25,000. And then an interpretation of the y-intercept. The y-intercept would be 0, 25,000. And that's if no donuts were produced. It would cost the company $25K. It's 25. I don't know what's going on there. $25,000. And then here's another example. If you want to pause again and give this one a try, then come back and check your answer. All right, so the population in 2014 would be 41,100 people. And the year would be 2020. All right, so moving on, example number 2 is sometimes we need to use a diagram to build a model. And so the scenario here is that Anna and Emmanuel start at the same intersection, and she walks east 4 miles an hour, he walks south. They're communicating with a 2A radio that has a range of 2 miles. How long after they start walking will they fall out of contact? So this, of course, would be their starting point. We want to know something about the distance. So here we could calculate Anna's distance as a function. A is a function of time. This would be her distance as a function of time. And we would calculate that at 4 times t, the number of hours she walked. And similarly, we could do that for Emmanuel's distance. And that would be calculated as 3 times t, by the 3 miles an hour times the number of hours he's walked. And then this distance that they are from each other, we can call that, we need that as a function of time as well, right? Well, the relationship here is that this scenario, because she is walking east and he is walking due south, that's a right angle from each other. So we can kind of use the Pythagorean theorem here. And so that relationship would be given by the distance as a function of time squared would be equivalent to Anna's distance squared, given by A of t, plus Emmanuel's distance squared, given by E of t. We can plug in for these functions, right? Like we have a value for A of t. We have a value for E of t. And so then we can actually solve for a linear function D of t. So what we're going to do is we're going to plug this in. A of t is 4t squared plus 3t squared. And then we can just solve. So if I solve out the right side of this, I'll have d of t squared equals 25t squared. And then taking the square root of both sides, I'll have d of t is equal to plus or minus 5t. And look, I have a linear equation. Now, because distance is always positive, I can just ignore the negative one. So just there's my function for the distance between the two as a function of time. And if you look back up at our problem, it says, will they lose radio contact when that distance is equal to 2? So how many hours t will it take them, at 5 miles an hour moving apart from each other to reach a distance of 2? And so the answer is just, solving for t, 2 over 5 hours. Which is equivalent as a decimal to 0.4 hours. And so we were able to use that model in our knowledge of the Pythagorean theorem to calculate the distance as a function of time and then solve for the time. So if you want to give this one a try, I'll let you pause the video and come back. All right, so let's see how you did. This will be approximately 0.384 hours. If you have questions, just see me during office hours about that try it problem. Just exactly like the previous example. So now let's talk about modeling a set of data. And so sometimes real world situations need to be modeled with two or more linear functions. And we do this with a system of equations. And remember, when you're solving a system of equations, we are looking for points where the two lines are having common. In other words, the intersection. So here we have a single solution because there's one intersection. Here, these are the same lines, so they're infinitely many. And here there are no solutions because those lines never touch. And so thinking about it, how many solutions would we have if the lines were parallel with different y-intercepts? And, based off what we learned last time, that would be no solution because they are parallel, therefore they never intersect. Okay, so using that, let's use a diagram to model a distance. And one of the tools that we can use when we're modeling a scenario like this is we can use a coordinate grid. And notice this is talking about, straight road leading from between these different towns, and these towns are, the cardinal directions. And so we can draw a coordinate grid. I'm going to draw a big one here. And of course, this would be due north, due east, due south, and due west. So let's take a look here. So it says that there is a straight road leading from the town of Westboro to Agratown. Well, our starting point, they don't call it the origin for nothing. So let's abbreviate Westboro and let's make that at 0, 0. And so we're then going to go to Agratown, which is 30 miles east and 10 miles north. And so that's going to place us, we went 30 miles horizontally east and 10 miles vertically north. And so Agratown, we'll abbreviate that, is going to be about here. And it says that there is a road that's passing in between them. That's not a very straight road, sorry. And then it also says that partway down this road, it junctions with a second road perpendicular to the first. And so this is perpendicular. And this road leads to the town of Eastboro. So we'll abbreviate there, Eastboro. Then it tells us that this town is located 20 miles directly east. So this point that represents Eastboro would then be, 20 horizontally and 0 vertically because it's due east. So it wants to know how far away is the road junction from Westboro. So what I'm actually looking for is this distance right here. And notice we just talked about points of intersection. So the way we're going to solve this is we're going to find the intersection point of these two lines. Now, in order to do that, we need to write the equation for both of these. And so I'm going to do Westboro to Agratown in red. And to write this function, the first thing I need is a slope. And so the rise over the run will be, I go 30 this way, that's the run, and 10 up. So that's 10 over 30, which is 1/3. And the intercept is 0. So this is y equals 1/3 x is this line right here in red. And then I can go back and I can find the Eastboro to junction line, which is this right here. I don't know what's going on with the internet connection. Sorry. There we go. So it's this right here in blue. And so the slope of a perpendicular line is going to be the negative reciprocal. And then I can write the general format of my perpendicular line, just like we did in the last section. And then I can use a single point on that line, which I have the Eastboro point. And I'm going to substitute that point in to obtain a value for B. And so this would be solving that out. That'd be 60 equals B. And so the equation for the Eastboro to junction would be y equals -3x. plus 60. And so, I have my two equations. Now, how do I find where they're equal to each other? Well, I just set them equal. So that would be 1/3 x equals negative 3x plus 60. And then I'm just going to solve for x. So just following the miracles of high school algebra, if you will, I will obtain that x is equal to 18. And then to get the y coordinate, I just choose either of the functions and plug that in. This is the easiest one. So I'll just plug that in for x, and that'll give me the corresponding y, which is 6. And so this location is 18, comma 6. And then to find this distance, which was the original question, we'll need to use the distance formula because we're going to find the distance between two coordinates. And so the distance formula, if you don't remember, is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're just going to use, these 2 points, this one and this one, and plug them into this formula. And so, in this case, you would end up with, basically 18 squared, because 18 minus 0 is 0, plus 6 squared, because 6 minus 0 is 0. And you'd see that the distance was about 18.97 miles. From Westboro to the junction. And so kind of putting a lot of different things together there. And here's an opportunity for you to try. If you want to pause the video and then come back to see how you do. Right. Ultimately, the distance in this case is going to be 9.6 miles from the road junction to Fortson. So if you have questions about that, get with me during office hours or bring me a question. And then finally, example number 4 has Jamal comparing the cost to use 2 rental truck companies. And at some point, because they have different ways to calculate their cost, they're going to come up with these different prices according to how far we've gone, right? So let's define our input as X in each case, and that's going to stand for, the number of miles. And according to the number of miles, we're going to have some output, right? Which is the cost. And here we'll call this, K of X, so we can keep track that this is keep on trucking, and we'll call this one M of X, so we know that this is move it your way. And so the first thing we want to do is construct our model. And so K of X is equal to, the rate, which is 59 cents per mile, which we said was X, plus the flat rate of $20. And then M of X for move it your way is 63 cents a mile, plus the fixed rate of $16. And so what it wants to know is, when will keep on trucking be the better choice? Well, the better choice is lower cost, right? And so what we're asking is when is K a lower cost? Is this lower than the other? So what we're actually looking for is, when is K of X less than M of X? That's fine, because we have these expressions for both. So we'll just, solve this inequality. K of X is this. We want to know when it's less than M of X, which is this. And then, we're just going to solve and isolate X. And using those algebraic rules of solving, we're going to find that, it's when X is greater than 100. And remember, X is the number of miles. And so when his mileage exceeds 100 is when keep on trucking is going to be the better choice, because it'll cost less at that point. And here's the graphical representation. So the graph of both lines, and the intersection is at input or miles 100. The cost will be 80 for both. And that's when you see that Keep On Trucking starts to be a lower cost there in red, then move it your way. So now, just like before, if you want to give it a shot and come back and see how you did. All right, so this is if she rents for less than 5 hours. All right, so the problem set is posted for this section. And as before, go ahead and make sure you've taken notes and tried a couple of these, and then come in ready with any questions and to continue practicing in class on Wednesday.